Thanks for coming to learn more about how to migrate and modernize enterprise workloads to GCP. I know it's the last session for the day. Must have been a long day for many of you, so we'll do our best to keep you engaged and alert. I'm Issy Ben-Shaul. I'm the Director of Engineering for Google Cloud, responsible for cloud migration products. Will be with me presenting Mark Serdze, who's the Director of Cloud Infrastructure for Trax Retail, a customer that will tell his experience, and Degany, who's a Senior Product Manager for cloud migration. We'll start from our base, presenting our base offering, mature, that has been deployed substantially within Google Cloud to migrate workloads from on-premises or from other clouds to GCP in a what's so-called lift and shift and optimize mode. We'll hear Mark talk about his experience, and then we'll shift gears and talk about our new offering that allows you to transform workloads from VM-based workloads into containers integrated in Kubernetes. So before we start, I want to kind of raise a question with the audience. How many of you have actually deployed production workload in a hybrid cloud? You raise your hand? OK, not too much, not too many. Good, so I'm glad you're here. Hopefully the numbers will change after the presentation. And how many of you have been involved in working on running applications as containers in GKE? OK, good. That's a larger number. Last question. How many of you would like to containerize more of your application workloads? Right, well, it's a biased audience. I guess that's why you're here. So good to know. Hopefully, we can help you with that. Just to set the stage, right? I mean, I think it's pretty clear by now that enterprises are shifting to the cloud. Not at the pace that one would expect, but nonetheless, the direction is clear. And the question is not if, but rather when they will actually migrate more workloads to the cloud. If you look at enterprise IT managers and asking them what are their top priorities, it's around moving more workloads to the cloud, expand the use of containers, optimizing cloud use because there's more workloads come in, you need to cost optimize, which actually is correlated to the container play, which we'll explain later and talk about it more. But the numbers are increasingly growing, there's no question, and Google Cloud is really making a lot of efforts to cater for those enterprises that want to move their workloads to the cloud. Oops, sorry about that. So why are they moving to the cloud? I think the reasons actually have been shifting as well. And what we're seeing now in customers is three major reasons why they want to migrate to the cloud. First and foremost, they want to basically stop managing infrastructure focused on their core competencies and get the great benefits of the latest and greatest storage, networking, computing, along with security, state-of-the-art security, reliability, performance, and best of all, managed by the great SRE team and not having to invest resources in making sure that everything is working. They also obviously like the on-demand nature of provisioning infrastructure versus having to wait a long time for it to provision and meeting the scaling demands instantaneously. But what we see is if you go up the stack, we see more and more enterprise customers that don't want to manage their system software, databases, analytics, logging, monitoring, right? And they want to switch to a managed service, right? It, again, has the best and latest services, including AI, ML, and everything that comes with the great of the platform, but also being managed by others. And if you go another level in the stack, into the application stack, we see more increasingly customers that say, hey, can we actually move away from the old way we develop and operate our application software and get rid of all the operating system instances that I have to manage within my growing, sprawling VM count farm and replace it with lightweight containers, right? And that allow me to do rapid deployment, portability, and everything that comes with it orchestration benefits of Kubernetes. So we see that shift very, very loud and clear. But the question is, why is it not happening faster? And the answer to that is, if we look at the enterprise, there is legacy, large, large amounts of legacy. And this is really hard to make the transition from the old world to the new world, starting with complex applications, multi-tier, right, with a lot of dependencies. If you're not careful, you move parts of the application, you keep one of the components on-prem, and latency will kill the performance. Very hard to identify all the dependencies and making sure it works. You need to deal with large amounts of data, sometimes petabytes of data that are on-premises and need to be accessible or migrate to the cloud. In some cases, there's shared storage requirements that do not fit what the cloud has to offer, and so it requires a lot of thinking about that. Then there's also the legacy way of doing things, let's say lifecycle management, as I mentioned before. And maybe most importantly, when you deal with production enterprise applications, you need to be risk-averse. You need to make sure that the thing will work, and if it doesn't work, and I can roll back quickly. So that's why moving from the old world to the new world is really, really tough, right? There's a saying that, the reason why it took God only 6 days to create the world is because he didn't have to deal with backward compatibility. So this is exactly what we need to deal with here in helping you. So we're here to help. Our mission is really, within Google Cloud, is provide a framework and a set of tools that really help you with that transformation from the old world to the new world, and gives you the ability to actually, in a stepwise and gradual fashion, transition. And by that I mean that we give you the tooling and the system methodology to actually shift to a modernized infrastructure, we call it migrate, and give you the ability also to go actually almost like vertically from old way of moving and developing applications into container-based workloads that are developed and operated within Kubernetes. Although it seemed like a sequential linear path, it doesn't have to be, and we're trying to, our vision is really to give you the options. You can actually first migrate and then modernize, or you can actually modernize on-prem and then migrate, or you can do both at once. And we give you all the options to meet your demands, and in some cases, you will have workloads or even specific application that is mixed, hybrid. Some of it will run on containers, and some of it, maybe the persistency layer will, for origin, will run on VMs. So all combinations are possible. And we'll talk obviously more about that. So we developed a framework and a methodology around it to actually take you from on-prem into cloud. And it consists of these 4 phases. And you can read more about it online, but starting with discovery and assessment phase, going into a landing zone setup, where you need to deal with all the identity, network security, billing, etc. And then once you know what to move where and how, you do the planning of what workloads to move first, and second, what are the called batches of application workloads that need to migrate together, and then you validate them, and eventually either lift and shift or modernize them, following by optimization phase in day 2. And we at Google Cloud and our cloud migration offering actually now offers 2 options, right? As I mentioned before, you can either go into what's called a migration factory and manage and move workloads in a lift and shift fashion, either rehosting or even replatforming. I'll talk more about it. Or you can actually modernize, and using our new offering of Migrate for Anthos, which helps you automate the containerization. But overall, we provide the full spectrum. So let's start with the base. As I said, it all starts with how to initially take workloads and migrate them into GCE or Compute Engine. For that, we offer our solution called Migrate for Compute Engine. What it does basically is consists of deployment of a virtual appliance on-premise that runs in your standard VM environment as a VM, and automatically deployed instances are run called cloud extensions are run in the region of your choice. You establish a connectivity between them. This is a fairly lightweight installation and deployment. Within a couple hours, you can be up and running, assuming you have a VPC set up and a VPN connectivity for the security and privacy of the organization. Once this is set up, we actually apply our streaming technology, which allows you to take a VM or a set of VMs that comprise an application, and then stream them into the cloud within minutes. Once they're up and running, they're fully operationally functional, again, within 5 to 10 minutes. And leveraging one optimization, they can access the storage that has not migrated yet. In parallel, in the background, we migrate the data into cloud storage, the cold data that has not been accessed during the ongoing operation. And this is done seamlessly, completely invisible to the actual applications that are running or the users. And once this phase is complete, you have the choice of whether to stay in that mode and make sure that you can validate that you meet the SLOs, the system working to your satisfaction. And if not, you can roll back instantaneously within minutes any of the workloads that don't fit what you expected. Sometimes the configuration problems or other elements. But once that phase is done, you can actually say, OK, I'm ready to cut the cord, so to speak. And then you apply a detach, and then you completely detach from your mothership, and you can decommission your workloads on-prem, and you're completely native, and the caching instances are getting out of path. So that's the normal process that we go through. And we've been migrating actually hundreds of, sometimes thousands of VMs per customer, some of our larger customers. So we have really enterprise readiness in our platform. We can migrate physical machines, VMs, AWS, Azure as sources. We apply right sizing to optimize the cost in the cloud. As I said, rollback, which is really important for the enterprise customers. Highly automated for scale with runbooks and APIs. We can also, coming soon, the option to re-platform your operating system, some 2008 R2 into the new version as part of the migration, and more. You can learn more about it. I'll switch to some of our customer experience. This is just an example, snapshot of one of our largest customers, Cardinal Health, that has moved tremendous amount of workloads within relatively reasonable amount of time. Again, 6,500 servers migrated. The majority using Migrate for Compute Engine. About 450 applications, lots of databases. Some of the applications were not migrated with lift and shift. They had to be rebuilt. For instance, some of the SAP landscapes was not running like old hardware. But for the vast majority, have been migrated successfully. But to get a little bit more of that, I want to invite Mark to tell his experience about using the product. Hi, Mark. Yeah. Hey, money. Oh,
so I'm going to start with just a few words about Trax. And Trax is a computer vision company. And what we do is we collect and analyze data in the physical world of retail. Essentially, what we do best is we go to stores, to supermarkets. We take pictures of shelves. We recognize everything that is going on those shelves, and we provide insights to our customers, which are usually large retail enterprises and also CPG manufacturers, a real-time view of what is happening in their store. So to be able to do this at a large scale, we built the most advanced cloud platform in the retail industry. And this platform every day gets millions of images uploaded from a range of devices, starting from mobile phones, IoT cameras that we install in shelves on the store, inside the stores. And we even have robots. And all this data is being automatically detected and analyzed by our machine learning models and our engines. And we are able to recognize every product on a SKU level. And this is very hard when you see a large shelf like that. And today we are proud that we are able to recognize more than 20 billion different SKUs around the world, 20 billion unique products. So what do we do with this data? We provide all sorts of analytics to our customers, starting from product availability, pricing strategies, planogram management, POSM materials, and their compliance in the store. And essentially, we allow them to take what they plan at the headquarters and move it to the actual execution in the field and close this gap and provide a better shopping experience for their customers. So Trax was founded 9 years ago, and it was actually born in the cloud. So it was a cloud company from the start. And we used most of the stuff you're hearing about in this conference. We have containers, we have microservices, we have events. So all the cloud best practices, we already had them. So why am I here talking about migration and cloud transformation? In 2017, Trax decided to adopt a multi-cloud strategy. So for us, it was a business need. We actually started to encounter larger enterprises, larger companies, and we understood that they have very specific requirements about the location and the security of the data and the type of company that they're going to give it to. And especially in the retail world, some companies view other cloud providers as a potential competition and very reluctant to engage in such processes. And we found out that if we allow them flexibility, an option to choose the cloud that they want, the process of engaging them is being more agile and more efficient. So we chose Google Cloud as our second cloud platform, and then we started to think about how to migrate all our services to this platform. Some of the stuff was obvious. It was very easy to plan how to deploy containers, how to deploy our services, how to deploy events, but we found that we have other systems too. Obviously, databases. I'm not going to talk about it, but there are a lot of solutions. There are a lot of challenges to migrate large databases between clouds. Besides that, we had legacy applications. We already been able to accumulate some old code that nobody wants to touch, and people are really reluctant to do anything with it. And I think the most challenging part for us is that we had highly customized BI tools that we offered our customers as a service, and they were developed and maintained by professional services teams. They were like large Windows machines with very high customization, non-machine like the other. And when you say about don't treat your infrastructure as cattle, as pets, but as cattle, these were very highly maintained pets. So, but still, we wanted to move them. There were a lot of considerations. Some customers required it, and in some cases, we found out that it's much more cost-effective to run it on Google Cloud instead of our previous cloud. And we thought about how to do it. So there was a lot of challenges. The migration is slow, it's unreliable, it's prone to network issues. There is no really guarantee that everything you're migrating and running will work as planned. You're always risking some downtime to your customer. And if it's your internal decision and it's not a customer request, you don't really want to bother your customer. And as a matter of fact, we tried a couple of those migrations with the BI tools, and we found out that this whole process takes about 3 weeks or so, and it involves several teams in the company, both IT operations and professional services, and we even had to call our third-party vendors for the BI applications. And we're kind of about to give up on that, and Then we found out about Migrate for Anthos. So Issy described many of the benefits of this platform. I can tell you what is great about it for us. First of all, it's free. And when you test some new product, you don't really want to commit and pay for it. It's really easy to set up. It took us an hour or so to do the whole integration between two clouds and the connection. And one of the most important things for us, it forced us to work systematically. This product has some mileage, and they have experience on the right way to do migration, which we didn't have. And we had to play by their rules, to create runbooks, to do validations, to be able to do rollbacks if something fails along the way. And it was really great for us. And I think the most important part, it just works. I like products that work and deliver on the promise, and this is definitely one of them. So to summarize, Migrate for Anthos allowed a single DevOps engineer in our team to migrate dozens of services with some planning, but the actual migration took just a few hours of copying the data and checking it. And we were able to decrease the time to deploy this by 2 orders of magnitude. And we didn't engage any external people for this. This was done inside the infrastructure. And ultimately, we didn't bother our customers, and they're still happy, hopefully. Okay. So I'm going to invite Adi to tell you about the next in this fascinating field.
Thanks, Mark. Hi, everyone. So you heard a lot about Anthos and GKE as the platform that it builds on. And what I'm here to do today is to answer a bunch of questions. Why do you need to containerize? What is Migrate for Anthos? How does it work? What's coming in the roadmap for it? And how can you use it? And I'll take you through some discussions. There's echo. I'll take you through the discussion about that. So first of all, what is Migrate for Anthos? Migrate for Anthos is a solution that you deploy into your GKE cluster, and soon also for Anthos on-prem and Anthos anywhere else that it runs. That allows you to take your VMware-based workloads or any VM workloads that you have on other clouds, like Amazon EC2 or Azure VMs, and migrate them over directly into a containerized form of the workload. Now, you would ask, why would I take a VM and put it in a container? The answer is, you're not taking a VM and putting it in a container. What we're doing is we're taking the legacy application that you have in the VM, the monolithic application you have there, and we containerize it. We strip away all the VM-related stuff, and we bring it into the efficiencies of running in the Kubernetes platform and the ecosystem of services around it. So I'll go in deeper discussion into that in this presentation. Now, what's important when it comes to migrating your legacy applications, your existing applications, is that typically enterprises will have a lot of those. They will have a lot of those, and you don't have enough people, enough budgets, enough time to go and rewrite and rebuild each one of these applications. And if you have a new platform that you want to leverage with a lot of new services and capabilities, if you cannot create a critical mass of workloads that you run on this platform, that you manage on this platform, you cannot really realize the benefits and the efficiencies of the platform, in this case, Anthos and GKE. And what we wanted to enable you to do is get your existing applications onto the platform, achieve critical mass there so that you can apply your policies, you can apply your business metrics, you can apply your logging and monitoring and the efficiencies, even though some of these applications will never get further modernized into microservices. They will still get the efficiencies of the infrastructure and the IT operations that you have there. So let's go one step deeper and talk about these efficiencies. Why would you take an application and containerize it? Okay? I think everybody is well aware of the benefits of building a new application in a microservices architecture and running them in a cloud-native format and leveraging Kubernetes for the orchestration and the platform benefits. But why would you take an existing application and containerize it? First of all, there's the infrastructure efficiency. When you take a legacy application that runs in a VM, it is constrained to the VM factor that you choose. If you choose too small of a VM instance, you need to resize it. Resize typically involves a downtime. If you resize it to something that is too large, then you overpay. So when you go and take this application, put it in a container, and then you put a lot of these different services or applications in multiple containers on nodes in the Kubernetes cluster, Kubernetes is dealing with managing the density, managing oversubscription of the hardware when the application is dormant or the duty cycle is low, and that gives you significant savings. And we've measured, working with multiple enterprises to assess their workloads, we've measured anywhere between 60 to 90% of savings, cost savings, hard dollars, that you can gain by this bin packing, so to speak. And this is significant, right? So if you have applications, and the applications are running with low duty cycle, they're running 50% of the time or less, and we'll see one of the customers that have some extreme scenario in that respect, then you're going to see significant cost savings without having to commit to a lot of infrastructure reservation in advance. Now, on that, put the infrastructure benefits of remediating and catching up with security updates, with OS updates, with kernel drivers that you need to update. If you have your workloads in VMs, and you have 1,000 VMs, you have to go to each one of the 1,000 VMs and update them. But before you update them, you need to understand what's there. So you need to deploy a solution to do the assessment and the monitoring and the reporting and the remediation, and suddenly you start to get a lot of overhead. So being able to delegate the kernel update and the security to a managed kernel in Kubernetes in GKE, that's something that gives you peace of mind and gives you, at the end of the day, cost savings in operations. Now, in addition to that, when you're working with Kubernetes, you're by definition working with infrastructure as code. So when you migrate your existing landscape, when you migrate your existing applications over to Kubernetes, you have the opportunity to go through a discovery process, understanding the needs of each one of these applications or services, which ports they listen on, what resource requirements they have, which storage volumes they use, and all that ends up in YAML files, and all that YAML file is something that you start managing as code in your Git repository. And that basically takes away the need to do another discovery later on in the future when you need to understand what you have deployed. So this is something that really takes all the information about your workload, whether it's the load balancer, the services, the ports, the resource requirements, and put them into the specs, into the deployment specs. Now, another important benefit is about unification of your application management and application maintenance practices. So think about that. You have your new applications developed as microservices deployed on GKE and Kubernetes, and now you have the number grow. You have a few of them initially, and then you have more. But then you have hundreds of applications and sometimes thousands of applications sitting on VMs and are managed with a totally different set of tools, different solutions from different vendors to deal with storage, to deal with networking, to deal with security, to deal with patch management. And now you have two environments that you need to pay for. And two environments where you need to do compliance and enforcement and verify that they all fit, and they also work together. Now, that is also getting you to a point where the IT skills that you develop are starting to diverge. You have the old skills and the new skills, the DevOps, the modern pipelines, and then you have patch management, package distribution, remediation, and storage management, and logical volumes, and all that legacy application structures that were accumulated in the last 10, 15 years. So unifying all those and porting the existing applications to be managed efficiently with the modern platform is something that gives you a lot of cost savings, a lot of efficiency, and the opportunity to start thinking about the future. When you move your existing application into GKE or Anthos, you can move it behind Kubernetes services, behind Kubernetes load balancers. You can move it behind Apigee for API front-ending, abstracting the application so that you can future-proof access to it while you're potentially modernizing certain elements of that application gradually as your resources free up. Now, some applications that you may have from the last 10, 15 years will never change anymore. Nobody touches them anymore other than implementing driver updates, security updates to the kernel, etc. Now, that's okay. You have the opportunity to leave them that way. If you identify certain applications that you want to modernize further, you can go and start rewriting certain elements of them, whether with serverless, whether with microservices. So the opportunity to switch over to the modern operations is where a lot of the cost savings come into play. Now, we talked about why you should containerize your existing applications. However, it's a difficult task. You have hundreds and thousands of applications, some of them written 10 years ago, some of them you don't know who the owner is, you just know that you need to keep them running and patched, right? And it's a very, very slow and very expensive effort to go get intimate with each one, understand how they work, understand how they access data, where they store data, how to break them apart into microservices. You can't do it when it comes to hundreds and thousands. It's just not scalable. So what we chose to do is to give you the opportunity to be selective in which applications you want to go all the way and modernize into microservices, and with which applications you want to modernize how you operate, how you manage, how you maintain them, but you're not going to re-architect them, but still move them over to the modern platform. And this is where Migrate for Anthos comes in to accelerate that. We see that acceleration for each application is capable of migrating the application in reducing that time to migrate from weeks to hours. And that's significant, regardless of where that application is. Combine that with the orchestration and the automation capabilities of Kubernetes that will now also orchestrate the migration for you, and then you have a truly scalable system to migrate your hundreds of VMs. And we see customers that are easily migrating 20 VMs in a weekend, right? And 20 VMs in an enterprise world is anywhere between 3 to 6 applications, right? So that's a lot. That's a lot. So let's talk about how it works. Now, when you migrate your existing estate, the first thing you need to know is what you have. And that's not an easy question to answer, right? Because the information, unlike with Kubernetes, where everything sits in deployment specifications, in YAML files, in the VM world, the information sits in multiple different places. You will have information inside the VM. You will have information in the VMware or the hypervisor configuration or the different clouds. You will have information in the routers, in the firewalls, in the VPNs, in your identity management. Everything sits in a distributed manner. So for that, Issy mentioned earlier the work that we've done with assessment and discovery technology partners, solutions like Stratozone, solutions like Risk Networks, Cloudscape, solutions like Cloudemize, right? These are tooling that are available at your disposal, and check with your Google representative if your project is large enough. You can get this tooling for free. So that allows you to go understand what you have, understand the business case, and which workloads will fit into VMs in GC, and which workloads will fit into containers. You will understand which ports they use, what's the application dependency in multi-tier applications or cross-application dependencies. Once you have that information, it's really easy to go and build the spec. And once you build the spec, just applying it to Kubernetes will orchestrate the migration. And from that moment on, you don't need to do discovery anymore. It's there, okay? Now, once you know what you need to migrate and you have these specs built, and we have references and examples and templates available online in our documentation, you can take these specs, apply them to Kubernetes, and in this case, GKE will go and start executing the migration for you, and in a moment we'll see how. Once the container has been created, the data has been migrated, you are free to roam in the Kubernetes world. Your container is fully portable. It can run anywhere you have GKE or Anthos. You can use any storage that is Kubernetes supported. So you can migrate across different file system types, different storage classes, etc. Everything that Kubernetes has to offer is yours to use. Same thing with the Anthos Service Mesh and Istio. You can now get business metrics for your legacy applications. You can tell which applications behave well and which are not, which application is a potential hotspot that you want to optimize further. And on, like logging into Stackdriver, like policy management, like security controls, and operating system optimizations, latest kernel patches and security. All these are managed for you. You don't need to deal with them. So even if your application was written on Red Hat 6 or Ubuntu 12, they will run in Kubernetes on the latest kernel with the latest security updates, and you don't need to go through a crazy OS upgrade, which in many cases entails an application upgrade, which in many cases entails having to buy a new license, and the story gets just worse. So let's see how it works. And I'll show a quick demo of the experience, and then we can talk about behind the scene, what the product is actually doing. So to start the migration, the first thing you need to do is define the source for that migration. Now, I'm showing you a snippet here of the YAML file that defines a single VM as a source. You can create as many of these as the number of VMs that you want to migrate. Okay, so for each VM, you have one snippet. The VM is specified as what we call a streaming persistent volume claim. This is using a CSI driver that Migrate for Anthos deploys onto your cluster. And what you need to define is the name of the VM for your storage class, and you will have different storage classes defined for AWS, for VMware, for Azure. The name of the VM or the ID of that VM, if it's, for example, an EC2 VM. You will define the model of migration. In this case, fully cached is the default recommendation. Fully cached means the desired state for this migration is that all the data will migrate. The other option is streaming. Streaming means we don't migrate the data, we just make it accessible in GKE, regardless of where the VM sits, so that you can do some experimentation with that without moving the data, or if you just want to copy subset of the data and get rid of the rest. And then the run mode. The run mode has two options. One it will shut down the source VM and will start it up in GKE. The second one is what we call test clone, and that's what we recommend to start with. Test clone will basically take a snapshot of your source VM, whether it's on VMware, on Azure, or AWS, and from that snapshot, spin up the container in GKE. Okay? So the application that you are migrating is still running on premises or in its source location, like AWS or Azure, and it's not affected. There's no downtime, there's no disruption. That application continues to run. However, now you have a carbon copy of that application available and ready to run in GKE so that you can experiment and you can test how the system will behave, what will be the right structure of Kubernetes services, what's the load balancing you want to set, what policies, what network access rules you want to define, etc., and run your validations there at your own pace. There's no hurry. Okay? Now, the data, while you're doing all that work, the data continues to migrate in the background, and that's what we call a prefetch into the caching system that you have. We will use that data later on to export into a persistent volume of choice with the storage class of choice that you have that you want to persist. Maybe you want to use SSD PDs, maybe you want to use Cloudflare, file store, or you want to use the NetApp cloud volumes, Portworx, Robin, any storage that is supported on Kubernetes and GKE is there for you to use. And I'll talk about the storage optimizations that we have there. So now that you've defined the source, you'll define the container to run. And this is where you do the quick test that I just described. The container starts right away. Doesn't matter if you have 10 gigabytes of data. Doesn't matter if you have 2 terabytes of data. The container will start in just a couple minutes. And the application will be available for you to test with. You can test whether you need to define any DNS or host aliases or load balancing, etc. That's all for you to test. It runs leveraging the Migrate solution streaming capabilities, so that data is available on demand. And then once you're ready, you're satisfied with what you saw, with the configuration that you have applied in the YAML, all you need to do now is export the storage that you have from that original source to a PV of choice, a persistent volume of choice. The export of storage is important because what it does, it modernizes your file system for this workload. And that's an important aspect. So I'll talk about all the stuff that we're modernizing, like networking and logging and the operating system and the kernel, but modernizing the file system is one important big step. Because when you look back at the 10, 15 years of workloads that you have in your estate, they were built using different storage solutions, different practices, different schools of thought. Some of them use LVM, some of them use BTRFS, some of them use RAID. They use small volumes, etc., and you don't want to manage that anymore. So we will flatten all that into a single persistent volume of your choice during the export process. We will also remove any unnecessary components from the file system that you want to filter out. By default, we do it for temporary files and swap files and things like that, but you can also identify areas that you don't need. So let's see, we'll switch over to a demo, and we'll see this in action, a very quick one. And then I'll go deeper into what optimization transformations we do. So this is just a minute. So in this demo, what you see is a two-tier application running in a VMware environment. There are 2 VMs. One is running CentOS, another is running SUSE 11, different kernels. One is running kernel 3, one is running kernel 2.6. And we have a GKE cluster available. what we will do is, first we will apply a YAML for the services for this application. A service for the application, the web application, a service for the database with the relevant ports and the relevant network rules. Once the services are available, I can go and start the application with the streaming operation, so you don't need to wait. Let's go and this is just showing the application working. What we will do is we will basically start the containers by applying the YAML to Kubernetes. Kubernetes will then orchestrate the entire operation altogether. Once the application is running in the container, you can leverage Istio. You can start seeing metrics for it. You didn't have to touch a single line of code. Okay? You didn't have to change anything with the application. And let's switch back to the presentation, and we'll see what transformations we're doing there. So if you look at the VM, the typical VM has elements that deal with the virtual hardware. You have drivers, you have the kernel modules, you have a bunch of services that are dealing with the virtual hardware, dealing with the VM itself. And then you need to deal with logging for the OS, logging for the application. And there's a lot of stuff that is related to managing that VM, okay, as an instance, because that instance is mutable. Now, when we take that VM, and what we want to do is first strip away everything that is not portable, everything that is there just to be able to run in that VM, on that virtual hardware. So the first thing that we do, we strip away the kernel and the drivers, and it doesn't matter what OS version that you're running, when you move into the container, you're going to use the kernel that is configured and running on your Kubernetes node. So even if you take Ubuntu 12 or you take Red Hat 5, you will end up running in Kubernetes in the latest kernel with the latest drivers, the latest security patches. The next thing that we do is dealing with logging. So we automatically transform the logging for syslog, the logging for console, and switch them over to report to the logging that you have configured in Kubernetes. In GKE, by default, that would be Stackdriver. You don't need to do anything. You don't need a syslog collector, etc. And then we automatically transform the networking. Whatever you had defined on-prem or in the source is discarded, and we configure networking to use the default networking or the native networking in Kubernetes. And that lets you use network rules and Istio, etc. And we talked about the transformation that we do to the storage and moving away from multi-volumes and logical volume managers to persistent volumes. So everything that you see in blue is managed now by Kubernetes with the native constructs. The only items that remain as your legacy applications are the items related to the legacy applications. So you will have your Apache services, you will have the cron jobs that you have set up, you will have whatever agents that you still need for that application to communicate with license servers, etc. All these are running. So you will have what we call a system container because it contains the sysv init service or user space service tree and the multiple processes associated with that. What we have in the roadmap is breaking that monolith down to multiple services and multiple containers, and that will be a subject for a talk next year. And what we also have coming out in a couple of months is also transformation of these system containers to extract the image and the Docker file and integrate that with CI/CD pipelines. So the sweet spot workloads for Migrate for Anthos today are web applications, application server, business logic, whether it's Java middleware with Tomcat, whether this is homegrown applications that you have, and complex multi-VM, multi-structure application stacks. If you have a lot of VMs that are running with low utilization, this is where you can see significant savings right away. What's not a good fit for it to run in Kubernetes today is if your application is using specific kernel modules, because you no longer control the kernel is managed for you by the node, or if your application requires certain uptime for single database configurations that do not have the corresponding cluster database or sharded database option on GKE, or it doesn't fit into Cloud SQL as a service. So for those, you can run in a hybrid mode between GKE and GCE. Use Migrate for Compute Engine to migrate those into VMs, and they will be accessible from your GKE cluster. And you can leverage the live migration capabilities and the uptime, even for single VMs. And before we end up, there's one important quote that I wanted to share with a customer that has used Migrate for Anthos to take their legacy estate, move it over to GKE. In their case, they have a lot of VMs that are operating in another cloud in a very inefficient way. They couldn't find the right way to right-size these because they are there's a lot of variance in their utilization, in their performance. And they were able to basically take hundreds of VMs and pack them into the cluster and get significant savings. The numbers that they realize are essentially around 10% of the cost that they had on an annual basis. So moving from $2 million a year to $200,000 a year. That's a significant savings just for the density. Migrate for Anthos is available now with general availability, and we have a bunch of good stuff coming out next year. So I mentioned the ability to extract Docker files, Docker images, and Docker create automatically Docker files to integrate with your source control and build pipelines, even for these monolithic system containers. The ability to split these containers into app containers and further slim them down. We're also adding support for Windows and the ability to run on GKE and Anthos side-by-side Windows containers and Linux containers with the same set of policies, with the same set of pipelines and network management with Istio. And, of course, support for Anthos on-prem, something that will come down the road. With that, you truly get the ability to make your workloads portable and run them wherever you need them to run, on whatever storage you need them to run, whether they are on GKE, whether they're on-prem, and whether they are running where Anthos runs. Now, the vision overall for the product is that you will be able to choose what to modernize, how much to modernize, and where to modernize it. Migrate first, modernize later allows you to create a critical mass. Modernize on-prem and leverage Anthos on-prems allows you to create portable applications that you have the future proofing of where you need them to run next, and the same development process for them. And of course, being able to move across these hybrid environments, this is where the next challenges are for all of us to address. Thank you for attending, and looking forward to your feedback. Please share it with us. This is a new product, and there's a lot for it to grow, and we need your feedback. We need your participation. Thank you.